Hello, everybody. So my name is JP Chen. I'm the SVP and the co-founder of XConn Technology. So XConn is a IC startup company focused on the connectivity solution for the AI computing and the data center. Our main product is PCIe switch and the CXL switch. So today my topic is about the CXL switch to enable a scalable and a composable memory pooling / sharing solution. Okay, so the scalable memory pooling and sharing solution is based on the CXL 2.0 spec. So people generally have seen this picture, which is being presented by the CXL consortium. So in this picture, the host, which is H1, H2, so you can see there's multiple hosts, where in the middle of these multiple hosts are connected to a CXL switch. So XConn today has a silicon, and we're bringing that silicon to production very soon. Then on the downstream port, a number of CXL controller or CXL memory devices are attached to the switch. Since there are many of these controller and memory device, they form a large memory pool. Then on the very left side, there is a management host, which running a function called a fabric manager. So this is a spec-defined function in the CXL spec. So with this kind of architecture, the memory pooling / memory sharing can be enabled. So right now, our switch, a single switch, can have up to 32 ports. Each port can be by 8 or by 16. We basically support by 8 bifurcation as the current product. And then we fully support the CXL Fabric Manager. And also we are, at this product, we're supporting a simple fan out of switch cascading to enable a very big memory pool. Okay, next slide. So let me talk about some of the application about memory pooling / sharing. The CXL is not new anymore. And during the years, we've been working on our silicon in the past 4 years. And in the past 2 years, we especially start working with our customer. So we're mainly seeing the application that utilize this memory pooling, which is supported by the CXL 2.0, are mainly in the following. First is the in-memory database. The in-memory database normally occupy a very large memory size. And because of the performance requirement, these databases have to reside in the memory space to be able to support the kind of performance requirement. So these databases normally can run, from 10 terabyte to, even 100 terabyte. And this is very, very hard to support with the existing kind of server architecture. So with CXL large memory pool, that can be easily supported. And also the database application, typically they basically need a memory sharing as well, because the database can be shared by multiple running applications. Also, the solution, before CXL memory pooling is using RDMA-based solution. As we know, RDMA is a very complicated protocol, and RDMA's performance is not very good in terms of latency. And in contrast, the CXL is a very simple protocol. It just follow a load store kind of programming. And also the CXL from the very beginning was designed to be low latency, high bandwidth. So the CXL memory pooling fit really well for this in-memory database application. Also, we've been working in the past, especially this past March, we worked with Samsung in the MEMCON for a demo using the memory pooling. And Samsung already demoed with the CXL switch supported memory pooling. The large in-memory database, such as SAP HANA, can have a great performance improvement over the RDMA or the non-CXL based in-memory database. Then another application is for AI inference. So AI is getting to the application stage, where the application means you're running the AI inference. However, AI, a lot of AI, they have a very large model. So very large model means when you do the AI inference, that model require a huge memory footprint. However, a lot of AI inference are running on some of the, not the top of line GPUs or the systems, so which are typically don't have enough HBM or the system memory. So we've been working with some pioneering company, for example, Memverge, to explore how to use the CXL memory pooling to enhance the AI inference. So the CXL memory can be utilized to do the AI inferencing, to utilize the large memory pool and huge memory expansion provided by CXL memory. And the last is basically the original solution to the memory wall issue that is the computing industry have been facing for many, many years, and also the lowering the TCO due to the benefit from the CXL memory pooling. So today CXL memory expansion pooling can already grow to a very large size memory pool. So originally the memory wall issue was there just not enough memory, which can be resolved by this big memory pooling. And also multiple hosts sharing a large memory pool. Through this kind of memory pooling sharing, the utilization of memory can be greatly improved. There are some other use cases that people think, to reuse some of the DRAMs in the outdated system, for example, DDR4, and continue to reutilize this through the CXL memory pooling. All right, so I'm going to briefly talk about XConn's product, the CXL switch from XConn. So we are the first company in the world that has a working silicon that support CXL 2.0 and also PCIe Gen 5. The switch has a total 256 lanes, which we can bifurcate to by 16 or by 8. And the chip we initially was designed to address this memory wall issue. So we really take a lot of work to optimize the port-to-port latency and the power consumption as well to make sure it's a competitive product. So the current product is already working with shipping CXL 1.1 processors from both Intel and AMD. And we're also getting ready to support the upcoming CXL 2.0 processors. And another good thing to worth to mention is our switch also work in a so-called hybrid mode. The hybrid mode is, this switch can connect to both CXL devices, host / PCIe device and host at the same time. And all these devices can work in simultaneously. So this is a good, this kind of hybrid mode provided a good environment when, you see in the market, a lot of PCIe devices, they are transitioning to be a CXL device. So a typical memory pooling box, the design of the design diagram would be looks like this picture. So in this chassis or box, typically there is a CXL switch, and there's a BMC and a management host. So the management host running the fabric manager, that can be either an ARM processor or an x86 processor. And the BMC and the management host, they work in synchronous to provide all the needed function to support the working of this system. So and the switch has so many ports, so some of the ports are used to connect to the host, and the rest port can be used for connecting to the downstream devices, whether those are the add-in card or the E3.S card. In this diagram, there's 4 ports that being utilized to connect to the host, and the rest port being utilized to connect to the CXL memory devices. But this can also change, depend on the customer's design. So just an example would be, the demo Samsung did in the March MemCon this year. So this is a rack scale memory pooling system where there are 3 servers and 1 of the memory appliance. So Samsung called that a CMM-B device. So these servers will connect to the memory box, which the memory box provide a large memory pool up to 16 terabyte. So the servers doesn't need to have huge amount of local DIMM. When they need the CXL memory or need the memory, they will go to the CMM-B, the memory pool, to request the memory resource and keep the application running. So this is a system that Samsung used to demo SAP HANA in-memory database and show a big improvement because of the CXL memory pooling, provided all the benefit of low latency and high bandwidth memory access. So we also mentioned the XConn switch also support a simple fan-out cascading. So in this diagram, you see it's a 2-level switching. So at the level 1, the switch connected to 3 level 2 switch. So the advantage of this kind of cascading is you can build an even bigger size memory pool because there's more downstream port to connect to the CXL memory device. Okay, so just want to give you some performance result of XConn's CXL switch. So this is a bandwidth testing result using the switch where the switch is attached to a CXL memory device. That CXL memory device is a by 16 memory device. So in this configuration, you see the performance of read and write in the different ratio. The one-to-one read and write go up to 52 gigabyte per second, and the 100% read will be close to 30 gigabyte per second throughput. We also show the latency performance. So in this setup, there is a two-socket host, which has a CPU 0 and a CPU 1. So the CPU will connect to local DIMM, DIMM, and it can also connect to a directly attached CXL device. And here, it also connects to a CXL switch, and the switch has a downstream port attached with a CXL memory device. The latency from a CPU 0, which is directly attached to the switch, and then go into the CXL memory. So the read round trip read latency is about 500 nanoseconds, where you see some other numbers for the directly attached CXL device is about 260. And because it's a two-socket system, if the other CPU 1, through the link to CPU 0 and to access the switch attached memory, that latency is add some further, the inter-CPU latency to become around 743 nanoseconds. All right, so just want to be a little bit forward-looking. So today we are working on the CXL 2.0 switch, but XConn is already working on a future product, which is a CXL 3.1, also a PCIe 6.1 switch. So we believe this kind of switch and the interconnect solution will fit into the future AI computing system really well. Because at that stage, the fabric connection will be formed by the CXL 3.1, right? And all the computing component, including the CPUs, memory devices, or some of the in-memory device, and the network card, they can be either CXL or the PCIe. And accelerator also supported the PCIe interface. So this kind of system will allow the AI computing system have a big, fabric attached memory network. So this will allow the system to do a lot of efficient AI computing. So that is my last slide. So in the closing, the CXL switch enable memory pooling, and it already provides a solution to the memory wall issue. And this solution can also be deployed to the AI computing as well as the traditional, HPC and data center computing world. And then even at the CXL 2.0, the software-enabled memory sharing, for example, some solution from MemVerge, the Gizmo software, it would already enable the memory sharing of CXL memory. So that kind of memory sharing solution will have a lot of usage case, a lot of application to take advantage of. And XConn definitely working hard with our partners and the ecosystem partners and the customer to make this solution to be able to deploy to the real usage case for memory pooling and sharing. Okay, thank you.